Well, welcome back. Here we are writing equations for these graphs, and we kind of set them up in the last video, and I told you I'd come back and show you how to do it, and we set it up by saying looks like, amplitude, frequency, period, and midline. So the first thing is I look at it and see what it looks like, and I see that it starts here in their middle line and it comes up here. So this looks like a sine curve. So I say it looks like sine. You can say SIN, which means sine. First thing we do is the midline, so I do the high plus the low, which is a -7 divided by 2. It equals y equals 0. Okay, so there's my midline. Then I come up the amplitude, which is high minus my midline, or 7. Because it's a graph, I can do my period first, and I go over here and count, and my period is 8, which is equal to 2 pi over my frequency. Flip their places or cross multiply, you end up getting pi over 4. So the formula would be y equals 7 sine pi over 4x. And I could say plus 0, but I don't need to. So we kind of had already done that one before, so I just wanted to have that for you. The one here below, we have it all set up. Looks like amplitude, frequency, period, midline. So this is actually the axis. This is kind of hard to see, but this is the axis from here and here. So if I look at it, this looks like it's starting in the middle and ends at the middle. So this looks like, actually right here, looks like the middle for this. And I see it's starting at midline. So this looks like a sine curve, but instead of going up and then down like it normally does, it's going down then up. So this is an inverted sine curve, so this looks like a negative sine. Okay, the midline is high plus low divided by 2. So the high is a -2. The low is a -4. Add them up, divide by 2. I end up getting y equals -3. And this is what this is y equals -3. Now, amplitude is high minus my midline, and the high we said was -2. And if I subtract a -3, I'm going to add 3 because subtracting a negative is positive, so my amplitude is 1. It's a graph, so I do my period first. How long does it take me to see this? And if you count it, it's 1, 2, 3, 4, so my period is 4. Equals 2 pi over my frequency. Flip their places or cross multiply. I know pi over 2 is my frequency. So this one is y equals negative sign because it's a 1, pi over 2x minus 3 because that's the midline. Okay, now that gives you a couple of examples of how you find equations. Let's look at the graph of tangent. Now I promise you I won't ask you to come up with the equations for the graph of tangent. Tangent is so much different because it has the distinct features of tangent is that it does not have a min or a max because of the undefined part. So there is no finite amplitude is how we say that. Number one, no finite amplitude. The second thing about this is the period is not 2 pi like sine and cosine, it's just pi. And if you'll notice right here in between when this is graphed, you'll see how it goes up to positive infinity, negative infinity. That's the asymptote here, where when you do your table, you always have an undefined part because the tangent of 90 doesn't exist. It doesn't exist. Or pi over 2, I should say. Okay? So here's where the asymptotes are at, we'll start in the middle here, pi over 2, and then there's a whole curve, and then it's 3 pi over 2, and it keeps going this way. Then if you went to the left, it'd be negative pi over 2, negative 3 pi over 2, and it keeps going that way. So you have asymptotes. They usually will say every k times pi over 2, and it has to be odd. Okay? Now the next thing is inverse trig functions. None of the 6 trigonometric functions have inverses that are functions. None of them. In order to discuss inverse trigonometric functions, we look at the original trigonometric function with its domain restricted. That's important that you know that, because none of them that if we were to reflect over the line y equals x or whatever would not be a function. We could discuss inverses for all 6 trigonometric functions, but we will choose only the sine and cosine and tangent. So let's look at these. Inverse sine, the first thing we do is select a portion of the sine function that is 1 to 1. Each input number is associated with exactly one output number and vice versa. There are many ways to do this. The graph below shows a selection chosen by mathematicians. The sketch to the left is the sine functions graph, so that's the one on the left that we saw last section. The sketch to the right is a portion that represents the 1 to 1. Okay, and if you look at the points here, if you see what they gave here for points, you're going to have to restrict it, because once you go past that, it's not a function anymore. All right, when you do the inverse. So that's the restriction. Notice that the values of the restricted sine function, the graph on the right, still range from -1 to 1, so that we still maintain all the values of the range of the sine function. Doing this makes our graph an invertible function instead of a periodic one. Okay. Now there's some things I want to show you on the notation of this. So I'm going to do it right underneath here before we go further. So if I say if the sine of A equals B, all right, so this is my input, this is my output, okay? The point on the graph is AB. But if I do an inverse function, then I can say this, if it's invertible. The inverse sine of B, sorry, let me erase that because the inverse sine, so I have to use this notation. The inverse sine of B equals A, then the point, it's an A, is B comma A, which makes it invertible. Okay, so let's look at it here. This is my angle here. Output is a number. So this is an angle and this is a number. When you do inverse functions, look how they're flipped. Now I have a number and then I get an angle. So it's like backwards. So let's try one. The sine of pi over 3 is a half, okay? Or, excuse me, pi over 6. I just made a mistake on that. Let's erase that. Sine of pi over 6. The sine of 30 is a half. Then I can also write, so the point is on my graph is pi over 6, 1/2 when I graph that. I can also write the inverse sine of a half must be then pi over 6. And then the point on my inverse graph would be a half pi over 6. I purposely didn't use degrees because we have to use radians a lot more in this course. Right? Now, so for the definition, when your y's are -1 to 1, so this, the inverse, you can see it as arc sine or inverse sine, see how it's written both ways, is x. Simply meaning sine of x equals y, 1 negative pi over 2 to x to pi over 2. So that's the definition. Inverse cosine. Here's a picture of cosine. I've highlighted here the part on the graph that makes it so it's invertible. Okay, it's not used as much as inverse sine because we can always use the inverse sine in place of inverse cosine. So I just wanted you to have this for your notes. As with the sine function, we need to restrict the cosine function in order to have an invertible function. We choose to keep the portion of the graph for input numbers between 0 and pi. So here again is our definition. Okay, and this one's between 0 and pi. The other one was negative pi to pi over 2. So I want you to notice the difference there. Okay, I want you to notice this region is a little bit different than it was. Okay. Inverse tangent is in one piece of the tangent function. The graph below is in one piece of the tangent function. Notice we restrict our view to the continuous region between negative pi over 2 and pi over 2. Unlike what we did with the inverse sine, the inverse tangent does not use either pi over 2. That should be negative pi over 2 or pi over 2. So let's put a negative here. Okay? So let's look at the region for tangent. So when my y's go from negative infinity to pi over 2, notice there's not a less than or equal to. It can't be because it's not defined at those. Okay? So here's some examples. I kind of alluded to it earlier. So the inverse cosine of 1 equals 0 since the cosine of 0 is 1. The inverse sine of pi over 2 over 2 is equal to pi over 4 since sine of pi over 4 equals radical 2 over 2. The inverse sine of negative radical 2 over 2 is negative pi over 4 since the sine of negative pi over 4 equals negative radical 2 over 2. And you can actually, on this negative pi over 4, is the same thing as saying 7 pi over 4, but you can use a negative and just make sure you go the different direction. And the inverse tangent of 1 equals pi over 4 since tan of pi over 4 equals 1. Okay, so we go through inverse trigonometric functions because the next video we talk about solving trigonometric equations.